So what we have here is we have kind of a graphic organizer that has everything we need to know about means and proportions. Right here it has all the conditions for means and all the conditions for intervals. I went ahead and wrote the 10% condition on means. In the past, sometimes I haven't used it as much because really when you have means, you don't have to look at that less than 10% population condition. Sometimes it's there, sometimes it's not. This year we haven't done a lot of talking about that in class, so we're just going to stick it here. It does not hurt if you include that, and it's just the same as over here. And if you notice, it tells you how to look at the different things. We've already know how to do a one sample. That's what chapter 22 was on. This week we're learning two sample, and so you have to, does one group affect the other? Paired is the next chapter. Okay, but so this has all the conditions you have, and it kind of has ideas and explains how you check them. Okay, the big thing that I wanted to go over with this is these new calculator steps we're going to learn. So in the past we were always having to draw the curve and then use the normal CDF. Well, we still have to draw a curve to show proof that we understand what's going on, but we are no longer going to use normal CDF or TCDF. What we're going to use is we're going to use these functions. And so the way you get them is you're going to hit stat, and then you go to tests. Let me get out my calculator. So I'm going to hit stat, and then I go to test, and here is all the tests we need to run. There's a lot of different ones. We will not use all of them. This process tells you which ones to choose. The t-test ones are straightforward. There's only one option on them. On z-test one, though, there's several options, so you need to make sure you choose the correct one. During this video, we're going to look at how we would do some problems before with normal CDF and then compare it with the new process. I think the ones that you're going to love the most are the interval, because you don't have to do the margin of error and do all the math. It's going to find it for you. Okay? All right, the second page, this top part kind of tells you what the different things are for means. It tells you what the t-score is, what the different standard errors are, and what parameters to list. Same thing over here. Proportion tells you what the z-score is, what the standard errors are, and what parameters to list. Right here, we know how to find degrees of freedom. For one mean, we do n minus 1. Two means, though, it's a pretty complicated formula that we're never going to use, so we just let the calculator do it. Okay? So when you have two means, you find the degrees of freedom in the calculator. And that's why I had to show you how to use this process in the calculator. Okay, so what we have here is what different lists are going to look like. Okay, so we have this t, that's the t-score. The p is the p-value. This one right here, this is the mean. And then sx, that's the standard error. And then that tells me my sample size is 11, so my degrees of freedom is 10. Okay, a two-sample t-test, you see how it has the arrow there? When you scroll down, you're going to get more of the information. But this is the degrees of freedom we're going to use. This is what's important. We have to be able to find degrees of freedom from a calculator. And so that's how we'll do it. Now, you can keep it as 39.6. You can make it 39, or you can make it 40. All of them kind of give you the same answer. There's kind of two different trains of thought on degrees of freedom, whether you round up or you round down. So whichever you do will work okay, and it will give you the correct answer. Okay. And then here's information on proportions, what they're going to look like. All right, what we're going to do now is we're just going to look at some different problems, and we're going to practice plugging them in the calculator. Okay, so here's just a sample. We're not going to check conditions. We're not doing any of this stuff. We're just looking at how the calculator function works. So percent is 30, and then the alternative null is that it's not 30, or it's greater than 30. And so what we would usually do is we would draw our curve, put 30 here, put 0.34 here, we would have to do our standard deviation, or standard error. And I'm sorry the thing keeps blurring and not blurring. I don't know what's going on with it, but this is what I got. So, okay, so then we would do this. Right? And then we would use all that information in normal CDF. So, second distribution, normal CDF. My lower was 0.34. My upper was a big number. I just put in my standard error formula right there. It was the same thing. And so we get a p-value of 0.269. Okay? And we would fail to reject. So it's not a huge process, but it's a little bit. You're going to see it's much more than what the new method is. So the new method, I still need you to draw your picture. Okay, but let's see. This is a one prop z-test. So we're going to choose number 5 that says a one prop z-test. So I'm going to go stat, calc, test, go to one prop z-test. I have 30 people. I mean, it's the null. And this, you see how it's P0? That means the null. The way I did this is I did 34 times 50. Now, I will tell you if you have a decimal on this, you need to round it. You're not allowed to have decimals here because it's supposed to be a whole number out of 50. And then my alternative is that it's greater than. And look, I got the same p-value right there. And that's my answer. So it's a little less work. There's not as much guessing on lower, upper. It just works. Okay, so now that's for p-value. What about a 95% confidence interval? Remember, for that we would have to do the old method. We would have to do our mean plus or minus our 1.96 times our standard error, right? And then we would add and subtract that. Well, this is what you guys are really going to like, because you don't really ever have to show any work for confidence intervals. You just have to interpret it. So I want a confidence interval, a one prop z interval. So stat, test, one prop z interval. It still has the information. Oh, I did a z test by mistake. Sorry. Stat, test, one prop z int. There it is. So it's still 17 out of 50. Confidence is 95. And there's our answer. It gives us to us right there. So the new method, you just have to use the calculator, which is pretty easy. You just have to remember the process. Now, if you have a problem like this where it's asking for the margin of error, remember you can find it by just subtracting those and dividing by 2. You could use the formula right here because that's the margin of error. Or you could just subtract and divide by 2. It's up to you. Okay? So, when we use the different tests, we're going to start practicing it more. But the stat calc test, or stat and then the test, don't go to calc menu, go to the test. It's pretty easy to use. And it makes it much nicer. Okay? And we'll practice this throughout the rest of the year. And you'll be able to use these functions the rest of the year. Okay, but now we know that they're here. And we know especially because when we run the 2-sample test, that's how we're going to have to find the degrees of freedom. Okay. And so that's what those are. It's the conditions calculations. If you would like some more practice on it in a